Hi students, good evening. So welcome to the session 9 of the laws of motion. So we are currently discussing the applications of friction, right? The problems where we will have the friction included. So already in the session 8, we have covered the understanding of the friction, like the types of friction, how do we estimate the value of the frictional force, all of it we have seen. Along with that, we just got into some very basic examples of how do we apply the concept of friction. This session we will try to solve a couple of more varieties of problems involving friction. Okay, so we'll start with the session. Look at this. A block 10 kg mass is placed on a rough inclined surface as shown in the figure. Like the way they have represented the figure, you can see this is the 10 kg block. It is put on the inclined plane. What is the angle of this inclined plane? 30 degrees. Okay, and if you observe carefully, they have given us both mu s value as well as mu k. Generally, remember what is it that we said? Mu k value will be generally less than mu s. In some problems we may approximate both of them to be having almost equal value, because some problems what happens is they will not give us two mu values. They will just say one mu. So in that case, we will consider that the kinetic friction coefficient is almost equal to static friction coefficient if they just give us the one value. Okay, so here clearly they have mentioned both of them. Mu s is 1 and mu k is 0.8. Question is what acceleration of the block will be. We need to tell what will be the acceleration of the 10 kg block. So check, when you look at the 10 kg block, right, it will experience a normal reaction. How the normal reaction is going to be? Just think about this 10 kg block. It will have a normal reaction acting normal to the plane. Then it will have its weight which is vertically down. But when we take the components of the weight, right, what will be the components of the weight? Mg cos theta will be perpendicular to the plane down. Mg sin theta will be parallel to the plane downwards. So this component is what will try to move the block down the plane. This mg sin theta, theta is what? The inclined plane angle. Theta is the inclined plane angle. Okay, so this is something that we are used to already. That is why I am not showing how we'll take the mg into components, because we have seen already a couple of other problems also. Okay, so here theta will be what? The inclined plane angle. Okay, now when there is a tendency to move down the plane, how the frictional force will be acting? Frictional force must be acting in opposite direction, right? Means it will oppose the tendency of motion. That is what we discussed about the nature of friction here. So friction will be acting up the plane. Now let us just substitute the values and see. So can we take g as 10 meter per second square? Here no, we might not even require the value of the g to be substituted. But anyway, look at it. What is the down the plane force that is trying to move the block? M is 10. We may keep the g as it is, because in the answer also they are giving g, right? So let us not substitute the g as 10 or anything. Let us keep it as g only. Okay, so m we will keep it as 10 because they have given us the mass is 10. Sin theta, theta is 30, means sin 30 will be equal to what? Half. And by the way, we also have cos 30. Yeah, what is cos 30 going to be? Root 3 by 2. So mg sin theta means what? 10 into g into half. That is like what? 5g. So that is the component of the weight that is trying to move the block down the plane. Now friction will be acting up the plane, right? Here first we need to conclude whether there will be a motion or not. How we will conclude whether there is a motion or not? If the force along the plane is more than the limiting value of static friction, then there will be a motion. Otherwise there will be no motion, right? So look at this. The motion is anyway going to happen along the plane, right? So perpendicular to plane, no motion is going to be there. Means what? There is a force balance. So perpendicular to plane, what is going to happen? The normal reaction value will be what? mg into cos 30. What is it? M is 10, g will keep it as it is. Cos 30 means what? Root 3 by 2. So here also 2 5s are, what is it? 5 root 3g. What is the value? 5 root 3g. Okay. Now, what is the limiting value of the static friction? What is the limiting value of the static friction? It will be what? Mu s into the normal reaction, right? Mu s value is 1. Means 1 into, what is the normal reaction value? 5 root 3g. So what is this? The limiting value of the static friction is coming as what? 5 root 3g. What is the force that is trying to pull the block down the plane? 5g. Now what is the conclusion here? The force that is trying to pull the block down the plane is actually lesser than the limiting value of static friction. Why? Because look at it. 5 root 3 means what? 5 into root 3 is 1.738. That is more than 5g. So what is the observation here that we are having? The component of the force that is trying to pull the block down the plane, which is the 5g, is lesser than the frictional force, static frictional force limiting value, which means what? The block will not be able to move. Why? Because static friction will adjust itself such that it will be able to simply balance out the component of the weight that is trying to move the block down the plane. So which means what will be the acceleration here? It will be 0. So here now we have to first conclude whether there is a motion or not. How do we check it? Sudhin, good evening. Okay. So how do we check it whether there is a motion or not? We have to see whether the net force along the plane is lesser than the limiting value of static friction or more than the limiting value of static friction. If the net force along the plane is lesser than the value of limiting friction, means the motion will not be there. Relative motion will not be there because static friction will adjust so that it will be able to simply balance out the force that is trying to cause the relative motion. Correct? So that is exactly the situation we have here. Okay. So in these kind of questions, right, first thing is we have to have the checkpoint whether there is a motion or not. And then how do we know if the component of the weight which is trying to move the block along the plane, that is mg sin theta, right, if that is more than the limiting value of static friction, means the motion will automatically begin. Here based on the numericals they have given, right, this is coming as what? Lesser than the limiting value of static friction. That is why motion is not going to happen. Hence they are asking us the acceleration, right? So if the motion is not there, means what will be the acceleration? 0 only, no? So we've been solving quite a number of problems on this inclined plane. So by now we should be comfortable in terms of resolving the forces. How do we represent the components? All these things we should be comfortable. Only then we will be able to quickly approach the problem. If we are taking time to even resolve the force into components and struggling in terms of indicating the directions, right, then we will never be able to proceed into the problem itself. So we should get that basic familiarity first so that we will be able to really focus on solving the problems. Okay guys, so what we'll do is we'll go to the next question. This is also a problem on the inclined plane. See, we are getting a lot of questions on the inclined plane. We must get a good command over these inclined plane type of questions. A block mass capital M is placed on a rough inclined plane. Same situation. A force is applied parallel to the inclined plane. How is it applied? You can see clearly it is applied along the plane upwards. How are you applying this force? Along the plane upwards, such that this block just starts moving upwards. The block is just starting to move upwards. They are asking what is the value of F. It's a very standard question. In fact, people remember this like a formula itself. Now, as it is, almost everything will remain the same. Look at this. We'll have the normal reaction and mg cos theta. Then we'll have mg sin theta down the plane. And here we are applying this force F upwards the plane. And statement, what they are saying? The force F is applied parallel to the inclined plane such that this just starts moving upwards. Just starts moving upwards means there is the tendency to move upwards. When the block is trying to move upwards, the frictional force, right? There is a roughness means there will be frictional force. How the frictional force is going to act? It will be exactly acting in the opposite direction, right? So we are trying to move the block up the plane. So frictional force will be acting down the plane. Okay. Now here the coefficient of friction is represented as mu. Here they are not saying whether this is a coefficient of static friction or coefficient of kinetic friction. Remember what I said? If they just give a mu value, right, then in those problems we have to assume that this mu represents both the static as well as kinetic, and we have to accordingly take the value. Okay, so look at it. So if we do the force balance perpendicular to the plane, no motion is there, right? Which means what? Normal reaction R is equal to what? mg cos theta. Now you might be noticing in some problems I am using a symbol n subscript r for the normal reaction. In some problems I am using n. In some problems I am using r. The purpose is to get you guys familiarity, because in some problem, right, they may just say that r represents the normal reaction, like that. We should not get that confusion. We should be open that okay, normal reaction can be represented by any of these three symbols. Okay, so normal reaction is equal to what? mg cos theta. Now this frictional force acting down the plane, what is the highest value it can have? The limiting value, what is it? Mu times normal reaction, right, which is what? Mu times mg cos theta. Now as per the statement, they are saying the force F is applied parallel to the inclined plane up, such that the block is just starting to move, which means what? The force F is applied up the plane. Both mg sin theta, component of the weight, is down the plane, as well as the frictional force is down the plane. When we say that the block is just starting to move upwards, means this F should be able to balance both the mg sin theta as well as the highest value for the friction. Okay, because if the F is able to balance the highest value of friction, means what? Even if you increase the F value by a little bit more, means the motion is going to start up the plane. Okay, so here for the motion to just begin, what is the condition? The applied force F should be equal to what? mg sin theta plus the frictional force limiting value, which is what? mg sin theta plus mu mg cos theta. Okay, so here in this problem they are taken the mass to be capital, but maybe while doing the calculation I might have put the symbol small m. There is only one mass, that is the mass of the block. Okay, so what is the answer for this? Option 2. What is it? mg sin theta plus mu mg cos theta. Check it up, guys. I am expecting you to respond to these questions because they are not that tough ones. So what is happening here? The condition of just block having a tendency to move upwards the plane. So as I said, right, this is a very standard question. People even remember it. So people remember it like what? To move the block up the plane, what is the minimum force required? That is what. So this F value, right, whatever is coming here, what is it? This is the minimum force required to start moving the block up the plane. What is it? mg sin theta plus mu mg cos theta. Next, look at this one. We have another question. The tension T in the string as shown in the figure. So it is like what? We have this 10 kg block on the inclined plane. Now look at this. What will be the forces acting on it? Normal reaction, mg cos theta, then there will be mg sin theta down the plane. That mg sin theta down the plane will give a tendency for the block to move down the plane. As a result, what is going to happen? The friction, because they're clearly stating mu means what? There is a friction, right? Friction will be opposing. Friction will be opposing. So friction will be acting up the plane. Also, what we see is that the block is attached to a point over here with the help of a rope. So what is this? This is the rope, right? They're asking what is the tension in the rope. They're asking what is the tension in the rope. See, first of all, let us understand one thing. If there is no friction, then imagine there is no friction. Then what happens? There is this mg sine theta which is acting down the plane. So the block will try to go down, and that is opposed by the force in the rope or the string, that is the tension. To balance it, right, the tension force value must be equal to what? Mg sin theta. To balance it, the tension force is equal to what? Mg sin theta. So if you bring in the friction part, friction also will oppose. Now, if there is a net force down the plane, after bringing in the friction, if there is a net force down the plane, then the rope gets tight and there will be a tension in the rope. See, previously there is no friction means what? The block is simply trying to go down, so tension has to balance it. If there is a roughness means we will have to see whether still there is a net force down the plane or not. If there is a net force down the plane means whatever the net force down the plane, that will be balanced by the tension, because the rope will become tight and that tension will come into picture. But if there is no net force down the plane means what? The rope will not become tight. You are connecting it to the hinged point, but unless there is a net force trying to pull the block down, right, the rope will not become tight. This point we have to be careful. Like this, you are putting a weight. If it is going to go down means the rope becomes tight and the tension comes into picture. If the net force down the plane is not there, means what? The rope will not become tight. Then tension in that rope or that string will be what? Zero. So this part we have to be clear. Now what is our task? We have to check whether there is a net force down the plane or not after looking at the friction part. So here since we are looking at the static situation, no relative motion, the friction part will be what? It is the static friction. Okay, now look at this. Theta is what? 30, right? M is 10. Theta is 30, M is 10. Okay, so let us substitute these respective values. So what we will be able to get? That force down the plane will be what? 10 into G into same. Sine 30 is what? Half, which is 5G. Okay, and maybe we can just substitute the value of G also. We can take it as what? 10. If you take it as 10 means it will be what? 50 newtons. Anyway, the block is held static perpendicular to the plane. There is an equilibrium, right? Like the way we have been always doing. What is it? That will give us the normal reaction value, which is mg cos theta. What is this? M is 10. G also we are taking as 10. Cos 30 is what? Root 3 by 2. This is what? 50 root 3. What is this? 50 root 3. That is the normal reaction. Okay. Now, static friction. What will be the limiting value of the static friction? Limiting value will be what? Mu, because we are assuming it to be the coefficient of static friction, right? Mu into the normal reaction. What is it? 0.7 into normal reaction is what? 50 root 3. So look at this. What is it? 0.7 into 50 means what? That is 35. 35 root 3. Now we'll have to just use a little bit of our basic math skill to check which is higher. So this is what? The component of the weight down the plane. This is the limiting value of the static friction. We have to check which is higher. This is 50. What is 35 into root 3 means? Check it. 35 into, we can maybe take it as close to 1.7. Root 3 is what actually? 1.732. Maybe we can just take it as 1.7 and check. So what we'll be getting? 7 5s are 35. 7 3s are what? 21. So 24. 1 5s are 5. 1 3s are what? 3. So 5, 9. What is it coming as? The value is 1.732. Even if you take it as 1.7, what is the value of 35 root 3 coming as? 59.5 is coming. Which means what? The down the plane force is lesser than the limiting value of static friction. But what about the static friction? It's an adjustable friction, right? Its value can adjust. So what is going to happen? The static friction will adjust its value such that it is able to simply balance this 50 newtons. So the object is held at rest. Now, is there any net force down the plane? There is no net force down the plane, because whatever the component of the weight along the plane is balanced. It is taken care of by the static friction. Limiting value of static friction is what? 35 root 3, that is somewhere close to 59.5. But the component of the weight down the plane is only 50, right? So the static friction will adjust the value so that it will balance it off. And there is no net force down the plane. If there is no net force down the plane, means it is like, okay, you are attaching to a rope, but when the rope will become tight, only when the block is trying to move down, right? But the block is not trying to move down, means what? Rope is attached, but the rope will be what? Loose, or we can say slack. So the tension in that rope is going to be what? 0. So this is an interesting question. Why? Because we need to understand when the tension will come into picture with regard to that particular arrangement. The tension will come into that scope when the block is trying to go down. That is when, right? The rope is connected, means the rope will become tight. If the block is trying to go down, means rope becomes tight. The block is not trying to go down, means the connection is there, but the rope will be slack or loose. So tension will be 0 in that case. Okay. So let us go to the next question. So guys, you need to respond. So these are not really that tougher level questions. We must be able to do them. Okay. The coefficient of static, it's not a friction, it's a friction. Okay. So the coefficient of static friction between block A, whose mass is 2 kg, and the table is 0.2. So mu value is what? 0.2. Mu means we are referring to what? Static friction coefficient here. Okay. What would be the maximum mass of the block B? Where is block B? Here it is hanging. What is the maximum mass of the block B so that the two blocks do not move? What is the maximum mass of the block B so that the two blocks do not move? So here we will take the value of G as 10 meter per second square. Take the value of acceleration due to gravity as what? 10 meter per second square. Let us see if any one of you will be able to give the answer for this. So what actually happens here? The block B is hanging, right? Let us say its mass is m. That's what we need to find, the maximum value. So the weight of the block B will be trying to pull the block down. Weight of the block B will be trying to pull the block down. Now, if the block B has to go down, then block A has to move towards the right side. If the block B has to go down, means block A has to move towards the right side. They are connected. But what is opposing the block A movement? Frictional force. What is opposing the block A movement? Frictional force. The frictional force can only reach a limiting value. So as we are adding more and more weight here, the downward pull force will keep on increasing, right? The block A can hold only up to its limiting value of the static friction. That is the concept here. What is the concept? As we increase the mass of the block B, the downward pulling force will increase. But that side, the force that is holding the block A at rest is what? Frictional force. It can only hold up to the limiting value. So that condition you have to use. So look at it. Let us say we are reaching that maximum value of B. In that case, what is going to happen? The frictional force here will be what? The limiting value of the static friction. Correct? So look at the block A diagram. Its weight is what? 20 newtons down. There will be normal reaction. Tension. Frictional force. When we want to find what is the maximum weight of B, right? The frictional force acting will be what? It will be the limiting value, correct? So here vertical block A is not moving vertically, it is moving horizontally only, right? So the balance of the vertical forces, which is what? Normal reaction will be equal to 20 newtons. So the limiting value of the static friction is what? Mu into normal reaction. 0.2 into 20. What is 0.2 into 20? That will be 4 newtons. Now the block A is held at rest by the limiting value of static friction, means the corresponding tension at this point will be equal to what? The block A is held at rest, right? The corresponding tension on this side, because only two horizontal forces, one is friction, other is tension, right? Tension is the one that is trying to drive the block A to the right. Friction is opposing it. The condition we are looking is what? The maximum value of the friction coming into picture. So the tension at that stage will be equal to what? The limiting value of the static friction, which is 4 newtons. Okay. So we get the tension. Now look at the free body diagram for our block B. Block B will have its weight mg, and that is balanced by the tension, right? Since they both are same rope with usual assumptions, right? The rope is massless, pulley and rope don't have friction. All these assumptions, the tension on both sides will be same. So here the force balance, this is also not, block A is not moving means block B is also not moving. Okay, which means what? Here also force balance, right? The tension is equal to what? Mg. But already we have a tension value that is coming from the equilibrium for the block A, right? So we will substitute it. 4 newtons is equal to what? Mg. G will take it as 10, no? 10 meter per second square. So M value will be equal to what? 4 by 10, which is 0.4 unit will be SI unit, kgs. Okay. So this is the maximum mass of B that can be held at rest. If we increase the mass of B, like we make it 0.5, we make it 0.6, like that, what is going to happen? The downward pulling force will be more and the system will start moving. B will go down, A will start moving towards the right side. Since they both are connected by the rope, their acceleration magnitudes will be same. That is something that we already talked in a lot of previous questions. Connected bodies, they are connected by the same rope, means they will have the same acceleration magnitude, right? Is it clear? So what is the answer for this one? 0.4 kg. That is the, what is this? This is the maximum weight of the block that can be held. So what is the condition we are using here? When this side we have the maximum weight, means a block A will be held at rest by the highest value of friction, that is the limiting value. That is the concept we are using. That's it. Okay. Let's see who can solve this one. A block of mass 10 kg is held at rest against a rough vertical wall. Like you have a book or something, you are holding it against the wall. Mu is given as 0.5. Okay. Under the action of a force F as shown in the figure. So we are applying a force F by making some angle. Here the force F is applied by making some angle. Okay. This is held at rest, means the friction that we'll talk in this case will be what? Static friction. Since we are saying it is held at rest, means there is no relative motion, right? The friction we'll talk in this case is what? Static friction. Okay. The minimum value of F required for this means, we can apply a force F and hold this block at rest. If we increase the value of F, means this will continue to be at rest. But the question is what is the minimum value of F by using which we will be able to hold this block at rest. But first of all, we need to understand what is the general tendency of motion for this block. It will have its weight, right? So it will keep going down because of the weight. There is a contact with the wall. The contact surface is vertical. So when it is trying to go down, the frictional force between the wall and the block will be acting up. Because it is trying to go down, means frictional force will be opposite direction, right? It will be acting up. Okay. So that is what is the representation of the forces. That's not over. We also will have a normal reaction, right? There is a contact, means there will be normal reaction. So we will have to represent all these forces. So look at it. There is a frictional force. Weight is there. So weight is what? M is 10 and G is also 10. So weight will be what? 100 newtons. Mg. And look at this. The normal reaction is, because this is the contact plane, right? Normal reaction will be normal to the contact plane into the object. Normal reaction will be what? Normal to the contact plane into the object. Okay, that is the normal reaction. Now this applied force F, look at it. Applied force F, it's making an angle 30 here. It is making an angle 30. Okay, so look at this. If you try to this is 30. So this will be what? 30. Angle made by the force with the vertical is what? 30. Now when you take this into components, right, you will see that F cos 30 will be vertically up. This is the force. Force is like this, right? You take a vertical component up. Horizontal component will be towards the left. That will be what? F cos 30 is vertical. F sin 30 will be horizontal. So understand this thing very clearly, because we have to be careful about the way in which we will resolve the F into components. Because here we are trying to study the motion, how horizontal, vertical, right? So look at this. This is the vertical line. The force F, right, is making an angle 30 here. Means if you extend this force line, these are what? Vertical opposite angles, means what? 30. So the force is making an angle 30 with the vertical. So vertical component will be what? F cos 30. What is the horizontal component? Vertical component will be force like this. Vertical component will be up. Horizontal component will be towards the left side. What is the horizontal component? F sin 30. Okay. Here sin 30 means what? Half. Cos 30 means root 3 by 2. So this is what? F into root 3 by 2. And horizontal component is what? F by 2. So horizontal component of the F is F by 2, which is towards the left. What about the vertical component? It is F into root 3 by 2. Vertical component is what? F into root 3 by 2. Now the block is held at rest. Means what? There is no horizontal motion, there is no vertical motion. So horizontally there is no motion, means force balance, right? That will give us what? That will give us the normal reaction value. What is the normal reaction value? F by 2. What is the normal reaction value? It is what? F by 2. Okay. Now once you know the normal reaction, we will be able to find out what is the limiting value of the static friction. Once we have the normal reaction, means we can find what is the limiting value of the static friction. So I am just erasing this part. So what will be the limiting value of the static friction? That is mu into the normal reaction. So the static friction limiting value, right? What is it? Mu into the normal reaction. Mu is what? Mu is 0.5. So 0.5 into normal reaction is F by 2. 0.5 means what? That also we can say 1 by 2, right? So 1 by 2 into another 1 by 2 will be what? 1 by 4. So this is what? F by 4. What is the limiting value of the static friction? It is what? F by 4. Now vertically also there is no motion because they are saying it is held at rest. Means do the force balance vertically. Upward force is what? Frictional force plus F into root 3 by 2. Frictional force plus F into root 3 by 2 is equal to what? 100. Frictional force plus F into root 3 by 2 is what? 100. Okay. Now from here, right, look at this. We want to have the case where the minimum value of F that is required. See, we are adding frictional force to the F into root 3 by 2, that is equal to 100. We are looking for this F value to be what? Minimum. If the F that we require is minimum, then the frictional force should have the highest possible value. It is like saying, we are saying A plus B is equal to some 100 like that. You want to have the B minimum means A should have the maximum value, right? If you want to have the second term minimum, second term is what? F into root 3 by 2 means we are looking for the F to get the minimum value, right? When it will be possible? When the first term, which is the frictional force, is having the highest value. Okay, so that is important. So for F to be minimum, the frictional force should have its limiting value or highest value. The frictional force should have its limiting value or highest value. Okay. Now we are done. We are done with the approach. It's just about getting the final answer. So what is the limiting value of the frictional force? What is it? Already we have it, right? What is it? F by 4 plus F into root 3 by 2 is equal to 100. Now take F common out. So F, in fact we can take F by 2 common out. Take F by 2 common out means first term we'll have a half, second term we'll have a root 3. First term we'll have a half, second term we'll have a root 3. That is equal to what? 100. Now we can even take the LCM here. What is it? F by 2 into 1 plus 2 root 3 divided by 2, that is equal to 100. Now other than F, let us take everything to the right side. Means what? 2 into 2, 4. That will go to the numerator. This 1 plus 2 root 3 will go to the denominator. Okay, so look at this, guys. F will be equal to what? 4. Already there is 100 in the numerator. Divide by 1 plus 2 root 3. Now this will ask some simplification thing from us. So what is this? 2 root 3. See, root 3, if you take it as 1.73 means 2 root 3 will be what? It will be 3.46. 2 root 3 plus 1 means 4.46, right? So 400 divided by 4.46 in terms of approximating it. What is it? 400 divided by 4.46. So we have to say approximately what will be the answer. So we have the answers in front of us, right? All the options are there in front of us. We have to check which of these will approximately match. I mean, we can do the division also. See, 400 by 4 means what? That will be 100. We are dividing by a number which is more than 4, means this value, right, should be definitely less than 100. The value should be definitely less than 100. Okay, means option 1 cannot be there. 400 by 8 will be 50. Here we have 4.46, right? Means what? This cannot be 42.7 also. Now we have to conclude which is the one, 89.7 or 95.2. Okay, so maybe we can just do some quick approximate calculation. If we try to divide 400 by 4.5, then maybe we'll be able to arrive at the approximate answer. That will be what? It will be close to 90. Check it, guys, whether we are getting it or not. So even if you just do that crude division also, we will be able to get it. So we can see 4.8, 4.58 will be what? That will be 36. Then we'll get another 8. So we'll see that this crude division itself will be giving us what? We are not taking 4.46, we are taking 4.5. We are taking a higher value. That's why we get 88 point something. If we take 4.46 means we'll get a value more than 88 point. That will be close to what? 89.7. Okay. So check it up, guys. We should be getting the answer as what? Close to 89.7. Okay. So these kind of questions, right, where we have a little bit more numerical part involved in terms of calculation, we should get ourselves some practice, and only we will be able to quickly arrive at the final answer. Otherwise, in this multiplication division, we should not take much time, because that will unnecessarily be the spoiler. Having learnt the complications of this fraction, everything, right, if we make a simple mistake in terms of doing the division, multiplication, addition, subtractions, then it will just kill the entire purpose, right? So we should be careful, one, not to make simple mistakes in that. Second thing is also how to quickly approximate and arrive at the final answer. That is the important thing, right? Okay, so I'm assuming we can go to the next one. Look at this one. We have a setup of two blocks. There is a 1 kg, there is a 100 kg. This is smooth. The plane between the 100 kg and the, we can say it as surface or a table, whatever it is, that is smooth. No friction here. But there is a mu given for the surface between the 1 kg and 100 kg, means there is a friction there. The frictional force acting on the 1 kg block is. So what is actually happening here? See, whenever we have a question like this, right, we should think as to what is happening with this system first of all. So here, if you observe it, right, there are no rigid connections. It is like we are keeping the 1 kg block on top of 100 kg block. 100 kg block is on the smooth surface. That is the arrangement. We suddenly start to apply a horizontal force of 10 newtons on the 100 kg block. We tend to apply horizontal force on the 100 kg block. Okay. Now, the 100 kg block will have a tendency to move towards the right side. The 100 kg block will have a tendency to move towards the right side. Okay. If it is moving towards the right side, then observe what is going to happen. The 100 kg block, just focus on 100 kg block. This is trying to move towards the right side. There will be friction acting on it to oppose it. And how the frictional force will be acting? Opposite direction. The frictional force will be acting in the opposite direction, right? And when we look at the 1 kg block, because of the 100 kg, this will experience a frictional force, right? Value will be numerically same, but direction will be opposite. So frictional force acting on the 1 kg block will be towards the right side. It is like what? Since we are applying a force, the 100 kg block will try to take the 1 kg block also towards the right side, because it will exert a friction towards the right side on the 1 kg. 1 kg will try to stop the 100 kg block. So the frictional force applied by the 1 kg will be towards the left. It is trying to stop the 100 kg. 100 kg is trying to carry on the 1 kg also along with it by applying a force in that forward direction. Okay, so this is how we look at the friction nature. The friction nature acting on the 100 kg and the 1 kg. But the thing is, if the frictional force is looked at, look at the 1 kg block. Vertically there is no motion, right? Which means its weight, we'll take the G as what? Let's say 10 meter per second square. Weight will be what? 10 newtons. Normal reaction is up. So normal reaction is equal to what? 10 newtons. So from here we can find what is the limiting value of the friction. What is it? Mu is 0.5 into normal reaction is 10. What is it? 0.5 into 10 means that is what? 5 newtons. The limiting value of friction that can act on the 1 kg block will be what? It will be 5 newtons. Now the question is, will the friction be 5 newtons, or because the limiting value of friction does not tell us what is the actual friction value, right? Limiting value of friction does not tell us what is the actual value of friction, correct? So how do we know what is the amount of friction that will be acting? If the friction is looked at, right, what is the main purpose of friction? To stop the relative motion between the 1 kg and 100 kg. Friction is what? To stop the relative motion between the 1 kg and the 100 kg. Now, if there is no relative motion, if there is no relative motion between the 1 kg and 100 kg, means what? The 1 kg and 100 kg, both of them will be moving together, right? If there is no relative motion means what? Because anyway there is a force acting on it. Below surface is smooth, so the 1 kg and 100 kg, they must be moving together. If between their surfaces there is no relative motion means what? They must be moving together. If they have to move together, right, let us see if they are moving together horizontally, then what is the corresponding acceleration? If they move together means we have to check what is the acceleration, right? Total mass will be what? 101. Total mass here is what? 1 plus 100 is what? 101. Applied force is 10. So acceleration is what? 10 by 101. Maybe we can take it as approximately 0.1. Approximately what we can take it as 0.1, right? Because 10 by 100 is what? 0.1. So we are taking approximately 0.1. Okay. Now, if the 1 kg has to move towards the right side with this much amount of acceleration, if the 1 kg has to move towards the right side with this much amount of acceleration, look at just the 1 kg here. There is only one force acting on it, which is the friction. If the 1 kg has to move towards the right side with this much acceleration, what is the relation we should have? The frictional force must be equal to what? Mass, which is 1, into acceleration 0.1, which is what? The frictional force should be equal to what? 0.1 newtons. So if the blocks have to move together, for that, what is the acceleration that will come for both of them? Approximately 0.1 meter per second square, right? And for the block 1 kg to have this acceleration, what should be the value of frictional force that is required? 0.1 Newton. What is the limiting value of static friction? 5 newtons. So in this case, will the limiting value of static friction act? No, right? Because the relative motion can be stopped just with a frictional force value which is equal to 0.1 newtons, right? We don't need to, because remember one thing, static friction will adjust the value, right? It will adjust the value from 0 to limiting value, which is 5 Newton. In this case, the static friction need not have to go to the limiting value. It can prevent the relative motion by just getting a value which is equal to 0.1 Newton. That's it. Okay, so what is the answer for this? The frictional force acting on the 1 kg block, which is static friction. The value will be equal to what? 0.1 Newton. So here we have to be careful about the static friction nature. That is the only thing. So if we are clear in terms of the understanding of static friction nature, we will be able to tackle these kind of questions. So whenever they are purposefully asking what is the value of frictional force, like these blocks given and movement is represented, right? Just think for a minute. If it is a case of the static friction we are talking about, then we should be careful that we are not blindly going ahead and giving the, some of us, the moment we may see this limiting value of static friction 5 newtons, we should not just come and tick it. We should be carefully looking at what is the actual value of the static friction that will come into picture, because static friction is not a constant value. It is a self-adjusting. It is a self-adjusting value, right? Next, we have another interesting question. In fact, I think this has come in one of the previous years also. Upper half of an inclined plane with inclination theta is perfectly smooth, while the lower half is rough. What is it? You have an inclined plane, theta. Something interesting. Upper half is more smooth. Lower half, exactly half of. If you take the length of the total plane is L, right? L by 2 is smooth, below L by 2 is rough. A body starting from rest at the top. So from the top there is a body which is starting from rest. Remember, it will experience a component of the weight downwards, right? Down the plane. What is it? mg sin theta. Okay. Body starting from rest at the top. What is going to happen to it? Because there is a force acting down the plane, it will start coming down with an acceleration. Here what will be the acceleration? The force is what? mg sin theta. So the acceleration along the plane will be what? Force divided by mass, that is equal to what? G sin theta. What is the acceleration of the block along the plane downwards? G sin theta. So it will get accelerated, means its velocity will keep on increasing till it comes to this point. Then read the question statement. A body starting from rest at the top will again come to rest at the bottom. Means by the time it is coming to rest, coming to the bottom, it is again coming back to rest. Means the second path, right? The second part should give a negative acceleration. We will call it as what? Deceleration. Because of friction, there should be what? A deceleration coming into picture, or negative acceleration. So the velocity will keep on decreasing. Initially, first half the velocity will increase, second half the velocity decreases, so that finally it is coming to rest. We need to find what is the coefficient of friction for the lower half. For this scenario, we have to find what is the coefficient of friction for the lower half. So here, right, like the way we do in kinematics problems, we have to divide the journey, first half and second half. Okay, for the first half, right, initial velocity 0, acceleration g sin theta. We will take that down the plane direction as what? Positive, so it will be what? G sin theta. Displacement is what? L by 2. Displacement means we are looking at along the plane. Everything is along the plane here. From this, can we find what is the final velocity? Final velocity means what? At the end of the first part of the journey. What is the relation we have? U, A, S, V. What is the formula? V square is equal to U square plus 2AS. This is the formula, right? U is here 0. So 2 into S is L by 2 into A is what? G sin theta. So 2 is cancelled. What is it? GL sin theta, that is V square, means V will be equal to what? Root GL sin theta, that is V. So by the end of the first part, right, what is the velocity that the object is having? Root GL sin theta. So we are done with the first part. First part is over. Okay. Now let us only focus on the second part. So first part is over, so we are done with it. Let us just look at the second part. Second part, again here it has to cover a displacement of L by 2. Again it has to cover a displacement of how much? L by 2. So we are only focusing on the second part. Okay. Now once we are going through the second part, just look at it. There is a down the plane component of weight, which is mg sin theta. But there will be also friction coming into picture, right? It's a motion. So friction is what? Kinetic friction. Normal reaction is what? Mg cos theta. Perpendicular to plane, there is no motion. So normal reaction is what? Mg cos theta. Okay. And here the friction is what? Kinetic friction, which is the constant value, right? So friction will be equal to what? Mu. This is the coefficient of friction we have to find. Mu into normal reaction. Friction force will be what? Mu into normal reaction. So mu into mg cos theta. Okay, that is the frictional force. Now what is the net force down the plane means? Net force down the plane means it will be what? It will be mg sin theta minus mu mg cos theta. Because of that, the acceleration will be what? We have to divide this by the mass, right? So m is cancelled. So what is the acceleration? G sin theta minus mu g cos theta. So what is the downward acceleration here? G sin theta minus mu g cos theta. So here one thing we need to keep in mind, this acceleration value will be numerically coming as negative. This acceleration value will be numerically coming as what? Negative. That is why it becomes what? Deceleration. No. Now we look at the second part of the journey total. Look at this. For the second part of the journey, initial velocity will be what? Whatever is the, like the way we have did in the kinematics, right? First part of the journey, whatever is the final velocity, that will be the initial velocity for the second part. So here initial velocity will be what? This one. Root GL sin theta. Final velocity when it is coming to here is 0. Displacement is same, L by 2. Displacement is L by 2. What is the acceleration? This much. Now look at what is the relation we have between them. V square is equal to what? U square plus 2as only, right? What is the relation we have? V square is equal to U square plus 2as. Means V square is what? V square is 0. Now we'll just have to substitute. If we substitute, we will be able to get what is the mu value. So here what are we trying to find? We are trying to find the mu value in terms of, if you take a look at these options, right, the final answer must be coming in terms of what? Theta. So look at this here. 0 is equal to U square. U square means what? We have to square it. Root GL sin theta, we square it, means it will become what? GL sin theta. Plus 2 into A is what? G sin theta minus mu G cos theta into S is L by 2. So the 2 will cancel. 0 is equal to GL sin theta plus another GL sin theta minus mu GL cos theta. We will take the negative term to the left side. Negative will become what? Positive. So mu GL cos theta is equal to what? GL sin theta plus GL sin theta is 2 GL sin theta. Both sides GL we can cancel it off. Mu cos theta is equal to 2 sin theta, means mu will be equal to what? 2 times sin theta by cos theta. Cos theta will go to the denominator. What is sin theta by cos theta? Tan theta. So what is the mu value? 2 times of tan theta. What is the answer for this? It is option A. So here what did we do? Just we have gone ahead with the first part of the journey and second part of the journey, we looked at what is the relation between the variables. First part and second part, what is the relation between the variables? So first part, whatever is the final velocity, that will be the initial velocity of the second part, correct? And using the relation, we are able to find out what is the value of mu, coefficient of friction, in terms of the angle of the inclined plane, which is theta. Okay, so with this we'll wind up today's session. So what you guys need to do is you should practice some more questions, because I mean you can keep practicing forever and ever, but the point is you need to at least get some self practice for yourself and make sure that you are able to proceed in terms of approaching the problems. That is very important. Okay, once you're able to get hold of it, right, with maturity and solving more number of examples, we'll be able to master this topic. Okay, so in the next class, right, probably we'll look at couple of more examples on this, and we'll get into the discussion of some more applications of the friction. Okay, so we'll see in the next class.